equation of line of best fit. We'll give this a heading 2. And we can read this off our graph. I can't really see very clearly here, but it's the black one. So it's 2.966 is the gradient, and the y-intercept is 0.07046. So I'll go insert new equation. So we want, on our y-axis, we had t is equal to, and the gradient was 2.966. And then we can put in a nice multiplication sign, times, and then we want the square root of mass, and then we want the y-intercept plus, whoops, we want that outside, so you just push right arrow to get out of the square root sign, plus, and then we want the y-intercept, which was 0.07046. 0.07046. Okay, there's our equation for the line of best fit, done in a beautiful equation editor. And then we want the equation of max error line. Is going to be new equation. Now we need to check the max error line, which is the steepest one. That's the pink one. And that has a gradient of 3.080 and a y-intercept of 0.048. T equals 3.08 times square root m plus 0.048. Okay, center. Equation of min error line. And now we use the blue one. So 2.85 and 0.111. T equals 2.85. Oops, I want to do this as an equation so it's consistent. T equals, what was it again? 2.85 was it? Yep. 2.85 times square root m plus 0.111. Alright, and then we center. Okay, so now we have these three equations. So now what we want, maybe I'll just put a little space here to make it nicer. So using the error lines, I can get an approximation of the range of the y-intercept and the gradient. So we want max gradient minus min gradient all over 2 is going to give us the approximate uncertainty in the gradient. So let me just put that over one of those. Over 2 equals, and the gradient we can say is delta gradient. The uncertainty in the gradient. Okay. Maybe we can just add another equal sign there. And so what do we get there? We get, once again, we add a fraction. So the max gradient is 3.08 minus 2.85. 5 over 2 gives us, what is that? That's 0.15 plus 0.08 is 0.23 over 2, so it's 0.115, which is equal to 0.1 to 1 significant figure, which is what we want in an uncertainty. The same thing is true for the y-intercept. So we take the max y-intercept, whoops, new equation, fraction, max y-intercept minus min y-intercept over 2 equals the uncertainty in the y-intercept. This is kind of a long, drawn-out, tedious process, but it needs to be done to get a sense of how accurate our equation was. So what is that? It is 0.111 minus 0.048 over 2 equals, well, what's that? It's going to be, what's 0.111? Okay, let's just ask Google. 0.111 minus 0.048 equals 0.063. Okay, thanks Google. 0.063, which is equal to 0.0621 SF. Okay, so our final equation after all of that. Let's write it in with uncertainty now. This is what it's all been building towards. Okay, so the time period is equal to our best value for the gradient, which is 2.966. But it's going to be plus or minus 0.1. So we only need it to 1 decimal place. So it's going to be 3.0. Oops. 3.0. And then we want to insert, what do we want? We want a plus or minus. Is that what this thing is? Yes, plus or minus 0.1. That's our gradient. Times square root of m plus, plus our best y-intercept, 0.07, and it's 0.7046, but our uncertainty is 0.06, so we'll just insert again plus or minus, plus or minus 0.06. Okay, now we have this beautiful equation of our relationship. So, and it's all quite neatly written with the equation editor. Okay, so that's the technical stuff. I hope that all makes sense. You can ask any questions that you have about it, either in the comments for the video or in class. Good luck with doing the concluding and evaluating part. I look forward to seeing your reports.